Hi, welcome to Coffee Calculations. My name is Eric, and today we're going to be continuing our conversation on axioms, particularly with the associative law. In my previous videos on this topic, I talked about a priori knowledge and how mathematics comes from a priori knowledge that is self-evident. I've decided I'm going to continue on that subject because it's important to know how we define a truth and how we know something is a truth and not just our perception of the current time. But I'm not going to do that in this video. I just want to focus on the associative law over addition and multiplication, and I will give a specific and a general case while also showing how over subtraction and division do not hold. So without any further ado, let us continue with the associative law over addition and multiplication. Okay, so the first thing I want to do when we're talking about the associative law is really, if you kind of step back, you can see that it's really another form of the commutative law in disguise. And what I'm just going to hint at for a moment here is how all this connects back to the truth. Because if we can see one axiom, it's really another axiom in disguise, and it's kind of like a domino effect. And if we go back to the original domino that knocked it over, and that one is true, and the one before it is true, we go back, and back, we can find that what is kind of the central pillar of truth. Once again, I'm going to continue that discussion on a priori knowledge because it's very important to understand this, particularly in today's age where there's so much stuff floating around us and information is so easily accessible. Anyways, back to the associative law. So first, let's just state the associative law in general. Once again, I'm going to use real numbers as A, B, and C. I'm not going to use the zero case because that will come in the next couple axiom lessons of Coffee Calculations. So for right now, let's just say A, B, and C are some integers in the real number system. So let's write it. Open parenthesis, A plus B, close parenthesis, plus C is equal to A plus open parenthesis, B plus C, close parenthesis. How we group over addition doesn't matter. That's what the associative law states. Let's look at that over multiplication now. Open parenthesis, A times B, close parentheses, times C is equal to A times open parenthesis, B times C, close parenthesis. Once again, law states over the associative law that it doesn't matter how we group them over multiplication. Okay, so now let's look at the associative law as it could be over subtraction. But once again, I'm just doing this to show how it could be, but I will show in the specific case how they do not hold over subtraction and division. So here we go. Open parenthesis, A minus B, close parentheses, minus C. We're going to assume would equal A minus open parenthesis, B minus C, close parentheses. However, it does not hold. I will show that in a specific case, so I'm going to put does not hold, just so there's nobody coming after me, later in the years, thinking I said something illegal mathematically. Okay, let's look at the associative law as it could be over division, but remember, it does not hold. A over B over C does not hold C over B over A. Those are the four general cases. Let's look at the specific cases and show how the first two hold and the latter two do not. All right, for the addition, let's use numbers 2, 3, and 4. A is 2, B is 3, C is 4. Therefore, open parenthesis, 2 plus 3, close parenthesis, plus 4 equals 2 plus open parenthesis, 3 plus 4, close parenthesis. All right, let's do the left side first and then the right side. So then we get 2 plus 3 is 5, plus bring down the 4. Well, 5 plus 4 is 9, all right? Let's jump to the right side before we write the equal to prove to ourselves that it holds. Therefore, 2 will bring down, plus 3 plus 4 is 7, all right? 2 plus 7 is 9. Let's look at it. 9 equals 9. Wonderful. The associative law over addition holds. Check. Let's look at multiplication. Open parenthesis, 2 times 3 times 4 equals 2 times open parenthesis 3 times 4 close parentheses. Now, let's do the left side first. 6, 2 times 3 is 6, times, bring down the 4. Well, 6 times 4 is 24, all right? Let's bring down the 2 from the right side, times, well, 3 times 4 is 12, and 2 times 12 is 24. 24 equals 24, check. All right, now let's look at the division. I'm sorry, let's look at the subtraction. Open parenthesis, 2 minus 3, close parenthesis, minus 4. I'm going to skip the equal or does not equal. 2 minus open parenthesis, 3 minus 4, close parenthesis. All right, let's look at the left side first. 2 minus 3, negative 1. Minus, bring down the 4, 4. Negative 1 minus 4, negative 5. Jump to the right side. Bring down the 2, bring down the subtraction. 3 minus 4 is also negative 1. Therefore, 2 minus negative 1, though, is positive 3. Negative 5 does not equal 3. Does not hold. Let's look at the division. 2 over 3 over 4, we're going to assume holds though 4 over 3 over 2. All right. Well, 2 over 3 over 4 is going to turn into 1 over 6. And the other side is going to turn into, we can go 4 divided by 2 is 2. We're going to be left with 2/3. 1/6 does not equal 2/3. Division of associative law does not hold over division, excuse me. Okay, so I've given you the general and the specific cases of the associative law over addition and multiplication, which it does hold, and does not hold over division and subtraction. It's important to understand these because these axioms are what give the mathematical power for us to infer all the mathematics that sit on top of these, first blocks of the foundation of mathematics. Thank you very much for listening to Cafe Calculations. This was the associative law over addition and multiplication. I hope to see you again very soon, and remember, enjoy the process.